Hey everyone, welcome back. Today we're diving into a super important topic that trips up a lot of people, the difference between correlation and causation. You've probably heard the phrase correlation does not imply causation. But what does that really mean? Well, let's break it down with some clear examples and visuals. What is correlation? Correlation means two things happen together. They co-vary, or how we say it here, they co-move or co-movement. When one goes up, the other tends to go up or go down too. But it doesn't mean one causes the other. One famous example is the phenomenon of ice cream sales increasing and shark attacks increasing. Does that mean eating ice cream causes shark attacks? Well, not really. Though these two things are correlated, they both rise during summer. It doesn't mean eating ice cream causes shark attacks. The hidden factor here is hot weather. So people eat ice cream or go to the beach for a swim because it's hot, which is the reason the incidences are high. But one thing doesn't cause the other. But what is causation? Causation means one thing directly causes the other. For example, smoking causes lung cancer. If you smoke more, your risk of lung cancer increases. That's a causal link. So there are two big reasons why correlation doesn't equal causation. The third variable problem. Sometimes a hidden factor causes both things, like the ice cream and shark attacks. The third variable is hot weather. Directionality problem. Sometimes two things are related, but it's unclear which causes which. For example, vitamin D levels and depression are correlated. But does low vitamin cause depression? Or does depression cause low vitamin D? We don't really know without more research. Let's look at some fun and surprising examples. Carrying lighters and lung cancer. People who carry lighters are more likely to get lung cancer, but the real cause is smoking, not the lighter itself. So how to tell if there's causation? Well, scientists use experiments to test causation. For example, randomized controlled trials can show if one thing actually causes another. Correlational studies can only show patterns, not cause and effect. If you will, you can think about looking at correlations as clues rather than cause. You want to find more clues that can point you in the right direction, which is why studying correlation is very useful for data analysis. So why does this matter? Well, mixing up correlation and causation can lead to wrong conclusions, like wasting money on useless products or blaming the wrong causes for problems. In this regard, is why for any wannabe data scientist, it's important that you team up with domain experts who know the business that you're analyzing, because things may be not apparent to you, but it might be very obvious to them when you do your data analysis. So you might want to get their help. For example, the lighter causes cancer mix-up is very obvious to us, but at times, the subject being discussed are things where you don't have expertise, and things are not obvious except to the experts. And you might be making statements similar to lighters cause cancer, which they can easily spot. So work with domain experts when doing your data analysis. So as a wrap-up, remember, correlation means two things happen together. Causation means one thing causes the other. Always look for hidden variables and directionality before assuming cause and effect. And then finally, work with domain experts for topics beyond your expertise. If you like this video, hit like, subscribe, and comment below with any weird correlations you've heard about. See you next time.